Hello friends, welcome back to Compiler Hacking. We're going to do something very, very simple in this video. We're going to implement the hypotenuse function or method on the math module. And there's not a lot to it. It is the square root of x to the power of 2 plus y to the power of 2. Basic math stuff. But to implement that, we are going to need square root as well. And square root is in the same module, square root. And so we're just going to wrap the square root from the C++ standard library and expose it in Ruby. So two methods that we need to be successful in this video. It's going to be hopefully short and sweet and to the point, but you never know. The reason this was brought up was our friend Victor had said that he had this really cool script. I don't remember what it does. I think it's Dijkstra's algorithm or something. It's pathfinding, but it didn't work because we didn't have a hypotenuse function and he had to do it himself. So I want to work on that. I already worked on srand in another commit, but I want to work on hypotenuse. Let's make Victor happy. Let's see what we can do. We already have a math module, but it is a very sad math module because all it has is a constant pi. So we want to add a few things to it. We need some C++. For the square root stuff, we need some C++. But the cool thing about Natalie is that we can do it in Ruby and then embed the C++ because we need a little bitty bit of C++. So I can do something like this. And I can do def self. This is a class method, square root. And what did they call the argument? Just x and so on. And then we can do, let's see, I forget. I think it's require Natalie inline, which lets us embed inline C++. And I'm going to have to go look at some other code to see how I did that. I think you just do underscore, underscore, inline, underscore, underscore, and then give it a string of C++. Pretty simple. Inline. And if I recall, I just remembered. There is a define method, which actually can take an argument. I think I did this somewhere. Where did I do this? Let's look for this. Define method helps if you type it right. Define method. Fiddle. I did this here. There it is. Okay, so we're going to do something like this, actually. So we don't even want any of that. We just want to replace it with this. We'll call this sqrt. Call this x. And then in our string, what are you complaining about? There we go. In our string, we can do return. I think someone added static integer. That didn't get merged yet. So we're in the process of adding floats. Oh, no, it is. It's right here. So you can just pass a double. Yeah, cool. So value, and the double will be sqrt of x. Is it really that simple? I don't know. If it is, oh, that's pretty cool. Okay, but before I save and test it, what I really want to do is spec core math. I know there's a math directory, and then I want to copy from the fantastic Ruby spec project, which we did not write, the spec for, let's see, core math, sqrt spec, and we'll copy that to our spec core math directory. And if I recall, now that I did that, I think someone added a, let's see, ls spec. There's a grab function. Ooh, what does that do? Spec grab. Do I give it, oops. Is that what that does? Ooh, it works, I think. So rm spec core, I want to see it actually work though. Sqrt. So if I run grab, spec file created. Ooh, nice. I should start using that, definitely. Okay, sorry, I got sidetracked. That was my first time using that. We want to see this fail. I haven't saved this file yet. We want to see this fail. So I'm going to rake and Natalie spec core math sqrt spec. And no return statement inside of function non-void. Oh, I thought I didn't save it. Okay, so let's do that. Apparently I did save something. Didn't mean to. It should say method undefined, I believe. Cannot load such file. Fixtures classes. Oh, we need fixtures classes. So can I do the grab thing for shared? Oh my goodness. I don't know. I don't know what it is. ls Ruby spec core math fixtures classes. So would I copy this? I would do spec grab this. I mean, at this point, I probably could have just done a copy, but sometimes it's fun to use the tools that we have. That it didn't like that. No such file or directory, because I don't have a directory. Core spec core math fixtures. So there's some work to be done there. Okay, so it did create the classes RB. Now I think we can run our test again, and maybe this time we'll get a method undefined error. Yes, undefined method square root. And so we got that a whole bunch of times, just over and over again. So we can work on this now. We can put this back, and I know we're going to need more code. I'm not going to write it yet. I'm just going to save it like that, and then run this, compile everything, run the test again, and we blow up. Okay, no matching function call for call to value brace and close initializer list. Maybe because this is not a double. Oh, okay, so X is a value, so we want to do X cert type value type. I don't get my autocomplete help because it's inside of a Ruby string, which is unfortunate. This is going to be a float, and this is going to be a float, and I believe I have to pass the environment here. And then this is going to be to float. Let's see, no, that's as float, and this is to double, I think. It's been a while. Hopefully that's right. Okay, float, not a member of Natalie value type. What do you mean it's not a member? Value type? Not value type. How about object type? Let's try that. We renamed value to object recently, so still getting that in my muscle memory. Undefined method square root for module. That's because when I ran define method, that's not creating a class method, but if I use this syntax, then it will be created on the class itself. Okay, undefined method square root for includes math. Okay, fascinating. So we got some work to do. We did get 3 passing tests, and we got 4 erroring tests. So let's just take them one at a time. Math square root spec line 6. So let's do that. Square root spec line 6 returns a float. So if it is an integer, what do you want me to do? So I'm going to say if x is integer, then we're going to say x is value double x as integer to nat int t. There might be a shortcut for that, but I'm not aware of it at this second. So we're just going to use that. Ooh, nice. I'm just going to use my little shortcut here to run this every time something changes, and then we'll go look at that, those other two failing specs. So no implicit conversion of math specs float into float. Line 28. 28 is here. Math specs float accepts any argument that can be coerced with float. Okay, math specs. So math fixtures classes, I assume, has this thing, and it has a 2F. So, if not, oh, you know, I just realized, because what I was about to do was call 2F here, right? But would that also fix this one? Because integer object has a 2F. Ah, I think it would. So I don't think we need this. We're just going to comment that out. Say if not x is float, and x respond to env 2f symbol, then we're going to call 2f. X is x. Send env 2f. Let's give that a try. That could work, right? Okay, running. Okay, something changed. Raises a type error if the argument is nil. So we need a special case for that. We did not need this, so we'll just reuse this. I'm going to say if it's nil, then env raise, and I forgot the syntax for that since I don't have my autocomplete. Guess I want to do this version. So raise a type error. Let's get the actual error message. So IRB math sqrt, and if I give it a nil, then we're going to copy that. Can't convert nil into float type error. Perfect. So now are we getting closer? How are we getting closer? Is inaccessible as a private is accessible as a private instance method. Undefined method square root for includes math. So line 34 of this spec, which is right here, 34, is accessible. New send square root should be a private instance method. Fascinating. Well, I guess I could do it this way. sqrtx call self class sqrtx, and does that accomplish the same thing? No, undefined method square root for class. Oh, because it's not a class. Okay. Well, could we do this? Yeah, because we're inside a module, not a class, so that doesn't work. Although this syntax is weird because it's not a class, it's a module. But, well, all our specs are passing, so I'm going to call that a success. So let's add this and this to our index, and then let's go work on the one we came here to work on, which is the hypotenuse. This one should be pretty easy because I'm just going to copy that. But first, we're going to do grab and hypotspec.rb. There it is. We're going to run hypotspec.rb. Don't need this tab anymore. We got a whole bunch of errors, of course, but we're going to do something like this. Hypot X and Y. Is that what they accept? X and Y. And we're just going to paste that in. X, just like that. And cross your fingers that we did everything right. No. We did not do everything right. Okay. We got 3 passing. Raises a type error if the argument cannot be coerced with float. Oh. You know what I just realized? That this was supposed to be the big float, not calling to F. Fascinating. So we should come back. Fix me. Should use float, not to F. I think. Okay. And then this is supposed to be float X and float Y. Okay, now we have 5 passing tests. Raises a type error if the argument cannot be coerced with float. Should have raised type error, but instead raised argument error. Invalid value for float test. Curious. Test. Are we raising the wrong? No, argument error. Okay. So interesting. X equals float X. Trying to decide how I want to rescue that. Maybe I should do this in C++. Rescue argument error. What? If I do IRB float test, if I do math.hypot test, can't convert string into float. So I would need to do these individually and rescue them separately. Well, this is a little more complicated than I thought, but it's okay. X equals begin, float X, rescue argument error. Then I want to raise, since I don't care, let's do it this way. X equals raise a type error and, oops. Let's copy this plus a C. Can't convert x.class.name into float. Maybe. I have a bad feeling about this. Not sure if this is right. Let's put this back. I'll get rid of that. Maybe. Okay. Undefined method hypot for, oh, and same thing down here. So we just want to do this. Let's do it in the other order though, because H comes before S. So let's move this down here. So they're in alphabetical order. Wrong number of arguments given 2, expected 1. Oh, of course. Why? Okay, so that should fix that one. Let's go back to this float to F thing. Let's fix that because this one should be fine. We'll go here, make sure that's still passing. It is, but what I'd like to do is, how am I going to do that? Because where is the float method at. It's not this. None of this. Kernel float. I believe I should do it this way. I should do kernel module float env. Then the value is x. And this would go down here. And so hopefully that makes some sense. It's going to call the float. Does it always pass keyword args? Is not optional. Okay, so I have to pass a null putter here. Really makes me want to make that optional. I wonder if there's a reason we can't. Let's do that. Okay, that's recompiling. I'm just going to look this over. So there's a little bit of a difference between this code and this code, right? Works completely differently. And I believe this is going to raise the wrong error if float fails. If the float function fails, it's going to raise an argument error instead of a type error, which might be a problem. Cannot call member function float without an object. Oh, that is right. But what happens? It's just a regular method on the module. It gets mixed into the object. Fascinating. How does that work? What is the object? It's the kernel module. I think I had to do, let's see, object the as kernel module for method binding. That is it. And then we call send env. I'm not in love with this syntax, but let's try it. And that's it. Okay. What's going to go wrong with that? Probably all kinds of stuff. Oh, right. That's not how you do that. So we do global env the object. I think that's the one I want. Yeah, this is getting a little gross. Okay, should have raised type error, but instead raised an argument error, of course. Invalid value for float test. So do I try catch this, catch exception object error. Let's put some braces around this just to make it very, very clear what's happening. And we'll say if error is a env. How does that work? Object is a env value. Env values. This is a value. argument error. So if it's an argument error, then we want to raise type error, and we want the error to be math square root test. Can't convert string into float. Okay, but it's not a, it's maybe not a string, so this needs to be something else, and X class inspect stir env. Okay, I'm pretty sure I messed up both of those lines. Const fetch. Okay, how do we do const fetch? This is probably a symbol, not a string. Okay, I have to go look up const fetch. Oh, we don't need the environment. Okay. Okay, no matching function call. Inspect stir. Inspect stir. You do pass that class. Candidate inspect stir parens. Wait a second. Wait a second. Why does this one take an env? What's up with that? Did I mess something up somewhere along the way? Module? Where did it say that was? Said it was in module object HPP. So is that the only other one? Is that one? Weird. I wonder what that's gonna break. Okay, fix me. Should take an env or should be gone entirely. We're going to come back to that. Remove that. This is why even something that seems very simple can quickly get out of hand. But we got all that passing. We ended up writing a little more C++ than I really wanted to. You know, I was just, as I was writing that, I was thinking, you know, which one's better, this Ruby or this big string of C++, which while I'm writing it, I don't get in my IntelliSense kind of pop-up stuff, which really slows me down. And then there's very unintuitive stuff like this object as kernel module for method binding, which is a very disgusting hack where we statically cast a regular object into a kernel object or kernel module, which is gross. And so it's stuff like that that really slows me down. And if I could just write the Ruby for it, it'd be really cool. I don't have a great way of, for instance, saying inline, and maybe that's what I need to fix. I need to fix it so I could say, you know, this code is going to be working with the X and Y variables, which in C++, it's not just X, it's like X43 or something, because it has to be unique. It's single static assignment, whatever it is. But if I could do that and then give it a block of code, or a string of code, that is, And then inside of here, do my math with X and Y. That'd be pretty cool, right? Well, maybe another day. Let's say this is good. This is good for now. This works. So we've got our square root and our hypotenuse. And that is working. And let's go add all that to the index. And let's follow up here. What happens if I delete this and then go past the NV here and save all of that? Module object CPP inspect stir. Oh, we're calling that all over the place. Look at that. So was that supposed to be okay, so let's go look at the object one. Object CPP inspect stir. This calls inspect. I see. But why could I not call that one? Okay, hold on. Let's put this back. That note can go away. This, I should be able to pass an EMV here. Class. A class is an object. Inspect stir. Candidate const inspect stir. Expect 0 arguments. Fascinating. But inspect stir is here. Why aren't you calling that one? Because this inherits from object. Weird. It should be overloaded based on the number of arguments, but it doesn't even see the other one. Okay. Binding gen, just curious. Inspect stir. Nothing calls inspect stir from here. Okay, I'll come back to that in another time. That's just weirding me out a little bit. I don't know. It doesn't make sense. It doesn't make sense. But let's make sure this still passes. And we'll call it good for this video. You know, sometimes it just isn't. It isn't sexy. It isn't. It just is. It is what it is. We're just going to remove that note, and we're going to say implement math.sqrt and math.hypot. This goes along with, let's see, closes number. Closes number 278. 278. Get push. And should pop up down here. There it is. And closed the ticket. Well, overall, not too bad. I feel pretty good about that. I don't love that we ended up writing all this C++ code to essentially just call this C standard library square root function. I'd rather write Ruby. I like writing Ruby. I think it's a little cleaner. And I mean, after all, we're writing a Ruby implementation, so we want to write Ruby. This isn't horrible, but it points out that our tools for embedding C++ or calling C++ from Ruby are pretty rudimentary, and they could be a lot better. So in the next video, I have some ideas. I'm going to try to work on making this a little bit better. Some way to do a one-liner call to square root rather than all of this, having to define the whole method. Not ideal, but anyway, always learn something when I do this with you. I hope that you learned something, and I hope you had fun. Hope you're working on something in your spare time that gives you some enjoyment. If you don't have anything, hop on over to our Discord. We have a fairly quiet Discord server, but every now and then there's a burst of activity. And lately people have been tearing up the pull requests. I think we've had a dozen this week, or maybe more. Yeah, this is just from 3 days ago. So here's several. It's been pretty great, actually. People working really hard on Natalie, and would love to have you if you want to contribute. So I guess that's it for this video. Hope to see you next time.